Okay, good afternoon. Let's get started here. Okay, what do we have going on this week? We have a quiz. Let's see. Homework 1's due tonight. I think most of you already have that in. Quiz is due Friday, and the project proposal's due on Friday. And some of you have already turned in some proposals. I've been looking through them and giving feedback. If you turn it in early and I give you feedback, you can turn it in again on Friday for a grade. I won't grade it the first time through. So if you want to take advantage of that, I won't promise that I'll get to it, but I'll make every effort to get to it. We're discussing basic Java syntax. So this week we'll do selection and loops, and then on Friday we'll do another discussion about the project. Today I'll go through the slides. On Wednesday I'll go through the code. I don't think that will take that long. I've put the code online. It is admittedly ridiculous, but just there to serve as examples of if then else statements, for loops, while loops, serves no useful purpose whatsoever other than for examples. If you have questions at any time, just yell out. Okay. As usual, at the end of the week, go back to these outcomes and see if you get them all. Convince yourself that you know them all. If you have confusions about some of these things, often it's best just to write a simple piece of code and run it and see what happens. I get a lot of, hey, can I do this? Can I do that kind of questions? Write it, run the codes, and see. It's often quicker than asking and waiting for an answer. Okay, 5 things every language must do. I think this is a good thing to know when you're learning new programming languages. Once you understand the paradigms, then learning a new programming language is trivial because it's basically learning the syntax of that particular language, but you already know how to use the language. So, you know, we're using Java as an object-oriented paradigm example, but once you learn the object-oriented paradigm, you can go to different languages that support objects pretty easily, particularly if you keep in mind that there's 5 things that every programming language must do. They have to be able to create and declare variables and bind values to variables. Usually that's called assignment. Not all languages use assignment to do that binding, but the imperative and object-oriented languages tend to. And we covered that last week. This week we'll cover selection and repetition. You have to be able to repeat sections of code. You have to be able to select sections of code to execute. Basically, you're turning on and off different sections of your code. And then you have to be able to do input and output. Input and output is always the part where programming languages differ the most, and it's usually the messiest, ugliest, hardest to wrap your arms around all the different options that are available to you. So we're doing selection and repetition this week. Once we're done with those basics, you know, then we're moving more strongly into how the object-oriented paradigm actually should work. Okay, what's selection about? I call it selection. The generic form is if then else. There are other forms and we'll go through some of them. It's turning on and off pieces of code. It's selecting which pieces of code are going to execute. That's so that the program can respond to user input. If the program doesn't respond to user input, it's frustrating and or useless. If you're playing a game and you try to move your character to the left and the game ignores that, then it's maddening. If you're playing a game and the game does not respond to any of your inputs, but just does the same thing no matter what, it's not a game, it's a movie. So there's no point to it. I say user input, and that makes you think about a human in front of a computer, but that's not always how that works. The input can be, and often is, file input. So if you think of databases, every month I get bills mailed to my house and or emailed to my email accounts, and that didn't happen because a human asked that to happen. That happened automatically. So how does that work? You know, some computer takes a file and inputs it, and that's the input, and then they run through the file and mail out bills to everybody that's in the file. So think of input not just as human action, but in file input, or data. You can also think of input as when computers are talking to each other and requesting things of each other. So this is happening right now. My computer is sending requests and data to a server, which is then sending requests and data to your computer. So computers that are talking to each other, one computer can be considered the user, and one computer could be considered the one that is responding to the user. The typical way that selection is achieved is through some kind of if-then-else form, and the most basic form is just that, if-then-else. If the something is true, do something, otherwise do something else. And then there are variations on a theme, but you don't need any more than that. Once you have the basic if-then-else, you have all the computational power you need. Everything else is making life easier for the programmer. And whenever we make life easier for the programmer, but we're not actually creating more capability, we call that syntactic sugar. So the if-then-else-ifs, switch statements, things like that, they can all be done with if-then-else, but they're easier to code, cleaner to code, less heartache for the programmer. So that's why those forms are in there. Questions so far? Okay, keep this in mind. Whenever you're learning any kind of an if-then-else form or a selection form, keep this in mind. You need to know you need three things. If you keep this in mind, then again, going to other programming languages can be a little bit easier because you know what you're looking for. You're looking for these three things. And the three things you need are a Boolean test. A Boolean test is a question, and the answer to that question is true or false. Technically, a Boolean system is any two-valued system. Yes, no, up, down, left, right, 1, 0. But we tend to think of it in terms of true, false. That's how it was first proposed. And in terms of an if-then-else structure, that's the best reasoning for it. True and false. If something is true, do something. If not, do something else. So the Boolean test that returns true, false. In other words, you can't ask, how much does that car weigh? Because that's a numeric answer. It's not true, false. You can ask, does that car weigh over 4,000 pounds? That's a true, false version. Then you need something to do if the test is true. You need something to do if the test is false. We call that true. If the test is true, we call it the true branch. If the test is false, we call it the false branch. It's called branching because people build up logic trees. Logic trees branch left and right, or true and false. And so that's where that terminology comes from. Once you realize that those are the three things, everything else is formatting. You don't need to worry about it. You just need to do it to match the language. MATLAB distinguishes the true branch and the false branch. They start with the line feed, and the true branch ends with the else statement, and the false branch ends with an end statement. So in MATLAB, it's if, test in parentheses, line feed, the stuff you need to do if it's true, else, the stuff you need to do if it's false, end. For Python, it's if, Boolean test, line feed, and then they use indentation actually. So they use indentation to designate the true branch, else, false branch is also indented. There's no end form because they rely on indentation. That's rather disconcerting to me, but that's just me. Java, remember, always uses curly brackets to designate sections of code. So once you remember that, it shouldn't surprise you that the Java form is if, Boolean test inside parentheses, open curly bracket, true branch, close curly bracket, else, open curly bracket, false branch, close curly bracket. You have to have some way of distinguishing that the false branch is done. Otherwise, the whole rest of the program becomes the false branch. So in MATLAB, it's the end. In Python, it's indentation. For Java and C and C++, it's the closing curly bracket. There are other forms. For example, in Excel, if you've ever done any work with the equations or the functions that Excel uses, the equal sign tells Excel that you're going to put in a formula, not a value, and then it's keyword if, and then inside the parentheses, they put all three things: test, true branch, false branch, separated by commas. I only put that in as an example that the formatting can be quite different, but all three elements have to be there. Okay, what's this deal with the Boolean test? I think, again, most of you are familiar with this. If you're not, don't panic. Just, or if it's been a while since you've programmed, just read up on these things, practice them, write silly programs that you think should equate to true and false. The basic Boolean test is always a question, never a statement. And the basic forms are things can be equal to each other, not equal to each other, greater than or less than to each other. So A equal B, that's the Boolean form of asking the question, is A equal to B? Now they use the double equal sign, two in a row. Why did they do that? Because that's already taken. That means A equals B. It's the equal sign is the assignment operator. It assigns the value of B to the variable A. So in order to do the Boolean, they had to do something different. That's different. So it distinguishes the question, is A equal to B, from the statement or the assignment command of setting the value of A equal to the value of B. I'll get back to this one in a second, the exclamation point. And then you get your normal math operators, A greater than B, A less than B, A greater than or equal to B. Now in math, that would be the greater than sign with a line underneath it. But that's not a convenient keyboard thing to have. So they just have the equal sign. Most languages would have the equal sign just follow the greater than. So it's greater than or equal to B and less than or equal to B. The exclamation point is called the not operator, and it flip-flops the value of the Boolean result. So not true is false. Not false is true. So what's happening here is you replace the first, I'm right there, you replace the first equal sign with the not operator, and now it's A is not equal to B. So when is that true? That is true when A is not equal to B. If A and B are both equal, then it will be false. And remember, these are all questions, not statements. If you've had exposure to Boolean logic before, you know the following. You know that the Boolean system is composed of two values, true and false, and three operators. All formal systems are this way. All formal systems have a small number of basic things or values and a small number of operators to modify those values. In the Boolean system, there are only two values, true and false. And there are only three operators, and, or, and not. An and operation, and this is how you write and in Java, it's the double ampersand. A and B, that's how you pronounce that, A and B. A and B is only true if both A and B are true at the same time. A and B. I'm trying to think of an example and blanking out, right? If I have cash in my pocket and gas in my car, I can go somewhere. Right? So you have A and B. I guess it's if I have gas in my car and the engine is working, then I can go somewhere. You need both of those things to be true. The OR operator only requires one of these things to be true, A or B. If I have cash in my pocket or money in the bank, I can buy something. Only one of them needs to be true. They can both be true. It's okay for both of them to be true. In logic, this OR operator is not the way we refer to it in daily life. In daily life, we say, for dinner, I'm going to have pizza or hamburger. Well, if you had both, that would be logically correct. But in daily usage, when we say, I'm going to have pizza or hamburger, then you are assuming as the listener that only one of those events will occur. Both of those events can occur. So if someone offers you, here's 2 pieces of cake, you can take the one on the left and you can take the one on the right. Technically speaking, you could take them both and you have not violated the OR operator. You have violated friendship, but not the OR operator. There is such a thing called exclusive OR, where exactly one of them is true. So the expression is true when exactly one of them is true, but that's not what we're dealing with here. And then we have the not operator, not A. If A is false, not A is true. If A is true, not A is false. I don't know, 80, 90% of the time, probably higher, you're going to do this. Every now and then you want to test 2 conditions at the same time with either an AND or an OR operator. You might have to do this sometimes, and we'll talk about that in order to flip-flop what's true and what's false. Okay, so here's the basic if-then-else in Java form. These are legitimate Java statements. Except they should be lowercase I. I have to apologize for that. That was PowerPoint helping me and I didn't go back and fix it. If X is greater than Y, there's your Boolean test. Open curly bracket, print yes, close curly bracket, else open curly bracket, print no, close curly bracket. That's the standard form with both a true branch and a false branch. Fairly often you don't have a false branch, you don't need it. You're allowed to leave it out. You can leave it in and leave it empty, that's perfectly legal. A little confusing to read, but you can just completely leave it out. If you do, leave out the else statement also. It's also perfectly legal to do nothing on the true branch. That will compile and run, but you should never ever do that. If you have, if true, do nothing, else do something, what you need to do is change the test. Flip-flop it from the true to the false. And here, one way to do it obviously would be to put that in there. But another way would be to literally put the not operator in front of it. Now I've flip-flopped the true and false values and I can move what I was going to do in the false branch to the true branch. Don't ever leave a true branch empty. It will work, it will compile, it will run, and you'll never get a job because people think that's nuts. Seriously, it's difficult for, it's more difficult for the human mind to comprehend acting on the negation than acting on the positive. You can nest these, you can put one if then else inside another, and you can do that again and again and again. Some programming languages restrict how often you can do that. Typically that difference, that limit is 7 deep. Some languages don't. I honestly don't know what Java does. I don't know if Java limits you or not. And the reason is you should never go that deep. If you're going that deep, 7 layers deep, you probably just got a horrific design and you should not do things that way. You should do something else. You can also, if you find that for some perverse reason you do have to go deeper than that, you can start throwing things into methods. Having a bunch of if-then statements is usually a sign of bad design. Having a bunch of them that are nested is usually a sign of bad design. Sometimes you can't help it. People do studies where they run analytics on commercial software, actual completed published software. And for really, really large programs, most of those programs, at least once in those millions of lines of code, will have nested if-then else's that are 3 layers deep or 4 layers deep. The average is about 3.4. Those numbers are a few years old. I'm not sure what the most current numbers are. I suspect that it's gotten a little flatter than that because it's kind of frowned upon. It makes it hard for people to understand the code, makes it hard to do code maintenance, and you really should be thinking when you're writing code about program understanding. We used to worry about saving memory space. We used to worry about computation cycles. Chips are fast and memory's cheap, so write to make your code understandable. Excuse me. The example I've shown is 2 layers deep because it's got one if inside the other. So when I say 3 layers deep, there would be another if statement nested inside here. And then when I say 4 layers deep, it would be another one inside of that even. And by the way, if you can follow that logic, good for you, but it might have taken you a half an hour to convince yourself that you were following it. And that's what I mean by code clarity. You want to be able to write code that can be understood more easily. Pausing for questions. When you have them, yell them out or put them in chat. Okay, a variation on this. Now, again, all these variations do not add any more capability to the language, but they do make certain programming situations easier to handle, cleaner for the programmer. So a variation on if-then else is using the else if. And what you're doing is you're kind of putting in a cascade of different Boolean tests. So it starts out, if this first test is true, do something. And then else if the second test is true, do something else. Else if another test is true, do something else. And you can make a whole bunch of these, right? There's no limit. And then you can either end or you can put an else in there, which serves as a default case. Now, you should always put that last else in here. You should always do this. And the reason is you might think that you thought of every possible outcome. And if your program is working correctly, you probably did. But if your program isn't working correctly, or if you did make a mistake, you need to have that default case down there at the end. And that default case could be something as simple as printing out a warning to you that something has gone horribly wrong. I've seen code where in certain sections of the code, all they do is print out, this should never happen. But that way, if it ever occurs, you know that something went wrong. And you know where it went wrong if you do it right, right? This should never happen, line 42 of the XXX file or the XXX method. Program defensively. Program to protect yourself. Program that if things go wrong, your code still runs and tells you about it. It takes a little bit more effort initially, but when you're debugging at 2 a.m., you may be very thankful that you did that. Switch statements are another form of if then else, and they take the else if form and they actually clean it up. I like switch statements, they're not used that often, but I like them. I never ever remember the syntax. Every time I think I'm going to do a switch statement from memory, I screw it up and I have to go look it up.
That's okay. You don't need to remember trivial things like all this index. You need to remember that they're there and what they're there for. A switch statement is used when you have a variable or an attribute that can only take on a small number of very specific values. And then what you do is break it up into cases. So instead of else if and then having the test, there's an implied test here. What this is really saying, case 1, and I'm going to change this. Case 4, case 42, case 54. Because it's not the first case, the second case, the third case. It's when x is equal to 4, that's what this means. When x is equal to 4, do this. When x is equal to 42, do this. When x is equal to 54, do this. Now the way Java works, and not all programming languages do this, so you have to read up on the specific language you're dealing with. The way Java works, if I do case 4, then this will execute, and unless I do something about it, everything below that will also execute. So at case 42, I would get this plus case 54 plus default. So how do you stop that? Well, sometimes it's useful. Sometimes it's what you want. So it's there for you if you need it. How do you stop it? You put in a break statement, and a break will just take you out of that case and dump you right down to the bottom of the switch statement. So an easy thing to forget is to forget to put your break statements in. And let's say you were setting a unique value to an attribute in each of those cases, and your attribute always has the same value no matter what the case was. Well, that's what's happening. It's going to have the last evaluation that you got. So remember those break statements. The other thing to remember is to include a default case, just like in the if then else. That's a typo, isn't it? Just like in the if then else, you needed that last else as a default. Put a default in there. Default means if it wasn't any of those cases, do this. Now, sometimes that's useful because maybe X can take on a really wide range of values and you only care about 5 of them or 3 of them. And so you're going to do something if those specific values show up. And then you have a default case if those values don't show up. So sometimes it's useful in that sense. But it's always useful, again, in the sense of defensive programming. Protect yourself. You might think you know all the values that X can take on, and you're probably right when your code is working correctly, but you know code doesn't always work the way you thought it would. You know there's some weird little error, 1,000 lines away in your code that are now affecting you, or 3 objects over in this case that are affecting you. And so you need to code defensively. And again, that default statement could even be something as simple as something has gone horribly wrong in the switch statement, in method, in file, something like that. This default case should never happen. It's not a bad print statement. When you're combining these, using the Boolean operators to combine logical tests that look like this. So if you recall, let's go back up here. The Boolean operators are and, double ampersand, or 2 vertical bars, or the not operator. So sometimes, and not that often, you'll want to test 2 things at the same time and them together or them together. I don't know, I'm going to take a wild guess here. 1% of the time? It doesn't happen that often. So here I'm testing X is greater than Y and X is greater than Z. In other words, X has to be greater than Y and X has to be greater than Z. Those both have to be true at the same time in order for that whole thing to be true, and we get the printout of yes. Otherwise, we get the printout of no. You can make as sophisticated and complicated and as ugly a Boolean test you want inside those parentheses. I've seen some horrific things that students have turned in where they're doing 4 and 5 tests and anding them and oring them together. Again, you're programming for humans, code clarity, code understanding,
a useful thing you can do, particularly in Java where we encourage this, is to create a method for that. Put it in a method. So you see here, all I did is I created a method, my Boolean test. That's a horrible name. Then we call my Boolean test, and what does it do? It returns the Boolean value. It returns true or false. And all it's doing is returning that same evaluation that you did. Why would that be better? Why do some people recommend this? And I'm recommending this, by the way, because it's code clarity. If I'm reading through your code, or you're reading through your code, you don't want to get bogged down with the details of those tests. You want to keep the flow of of the logic of the code going, the flow of the behaviors of the code going. So I recommend, and others recommend this also in the software engineering community, putting that in a method. Now, would you call it my Boolean test? Of course not. You'd call it whatever it is that you're actually testing. Test that X is the biggest value. Or even name it, is X the biggest value? Ask it, name it in the form of a question. No question marks though. Name it in the form of a question. It helps with code clarity. It helps you understand what's happening. If you need to know the details of what that test is, you can always go look at the method. Some people propose that you always put Boolean tests in a method. Now, why would they do that? That seems like it's extra work, counterintuitive. First of all, it makes the code longer. It takes up more memory space, and whenever you call a method, you're wasting computation cycles. All of that is true. But again, I cannot tell you this often enough in the course. Chips are fast and memory's cheap, right, for humans. So if you, instead of putting in a Boolean test, you always put in a Boolean test that has a descriptive method name, it is easier for humans to understand what's happening. In the software engineering community, one of the things that people have ignored for decades, and unfortunately still ignoring now to some degree, is the ability to write code that can be maintained over a long period of time. So that's what this is about: code maintenance, code understanding, code clarity. What would happen if you had to do this on a project and you left the project and somebody else had to come in and finish the project? Would they have to start over, or would they understand your code? That's becoming a critical question. It has been a critical question in the software engineering community. So people are more and more writing tips to clear that stuff up. And again, you think through the logic of it. You're coding. A week later, you're going back over your code. What do you have to do? You have to think through the logic again. So what was I doing here? Oh, that's what it was. That's what that means. If you do it with the descriptive method name, it tells you what you were thinking at that time. So that's my speech about good format with the Boolean test. Now, in fairness, I don't always do that in my own code, but it's a good it is a good practice. Okay, before we move into loops, are there any questions about if then else's or selection? Okay, all we'll do today, we'll go through the slides. I have sample code up. Like I said, it's hideous, but it does show the examples. And we'll go through the code on Wednesday. And then on Friday, of course, we'll have our lecture on project stuff. Okay, repetition. Repetition is where you're able to select parts of code to repeat over and over again. Again, why? This is allowing you to have the program respond to user input. And most particularly what's happening with this response, this is about responding to data sets of particular sizes. So as you know, you normally have a data set, let's call it a list, and the list has, say, 20 items in it. You might have to do something to each element on the list. If you hard-coded your code so that it would do everything to the first element, the second element, all the way down to the 20th element, and then you decided to add a 21st element, you'd have to go back and change your code. So that's what loops are about. They're allowing you to handle different sizes in the data without redesigning, recompiling your code every time the data set changes. Now think about, well, how often does a data set size change? All the freaking time. Look at you know, a data set like the number of students at Embry-Riddle Daytona Beach. It changed like crazy all summer, and then it changed like crazy through add drop. It's going to change again as the semester goes on. So the ability to do repetition means that your code can handle data of any size. There's two forms of repetition, and that's why I use the word repetition, because it's the most generic term. There's two forms of it. One is iteration. Iteration is when you're doing one thing after another, where typically you're calling one method over and over and over again, or one method calls another method over and over and over again. That's iteration. There is another form of repetition though, and that's recursion. And recursion is when a method calls itself over and over again. Iteration can be thought of kind of as skipping along the surface, and recursion is going down into the depths and then coming back up from the depths. So we'll talk about recursion later on in the course. It's not critical for the course. We do not have any specific reason to highlight recursion. There are programming languages like Lisp, though, that do not have for loops. They only allow recursion, or at least the original forms do. So be aware that recursion is sometimes your only option, depending on what language you're in. And sometimes it's just flat out the best option. So when you take, those of you that take CS225, the data structures and algorithms course, you'll discuss recursion a lot more. In CS232, you'll discuss recursion more because we talk about functional programming languages. Sometimes it's just the right tool for the job. But in this class, it's going to be for loops and while loops, and it's basically going to be for loops. Most students just need for loops. Every now and then you need the while loop. Well, what about for alls? What about do whiles? They are the same thing. They are syntactically different. They may behave slightly differently, but if you understand the basic concept of a loop, you know what all of them do. For loops, while loops, for alls, do whiles, what other variations exist out there. None of them have any more capability than the other. Every for loop can be converted to a while loop. Every while loop can be converted to a for loop. None of them have any capability difference. They have syntactical differences that lend themselves to different situations. Usually, as you know, when you know ahead of time how many times you need to go through the loop, you're going to use a for loop. Usually, when you don't know ahead of time, you use a while loop. But they can be converted back. Okay, just like there was 3 things needed for selection, there's 3 things needed for repetition. And the 3 things needed for repetition are pretty simple. One is a starting condition, a stopping condition, and then progress. How do I get from start to stop? Most of us have experienced making an infinite loop before. Well, we had a starting condition, but we screwed up the stopping condition. I would argue the stopping condition is more important than the starting condition, because things really go wrong when you get into a loop and it doesn't stop. So starting condition, stopping condition, and progress. If you don't make progress towards the stopping condition, once again, you're in an infinite loop, which is normally a bad thing. Sometimes it's the right thing, like smoke alarms, right? They should be on an infinite loop. They shouldn't stop. But usually we want them to stop. Okay. In Java and other similar languages, and I'm not giving you all these different language forms this time, I'm just jumping right to Java. You have the 3 things that are needed right in the first line of the for loop. So the for loop starts with for, what a surprise, for, and then inside parentheses, you have the start condition, semicolon, stop condition, semicolon, progress. Now, if you came from the MATLAB world, go back to your MATLAB syntax and convince yourself you know what the starting conditions, stopping conditions, and progress are, how they're represented in the MATLAB world. And then I think it makes it easier to make the transition to Java. And again, once you do this 3 times, 5 times. It's just as natural as anything else. Everything inside the curly brackets, we call the loop body. Yes, you can nest loops just like you nested if then else statements. So you can have loops inside of loops. But the key is we need start condition, stop condition, and progress. Now, while loops are a little bit different. You have to set up the starting conditions ahead of time, and then you use the keyword while, and you only have the stopping condition specified in parentheses, open curly bracket, close curly bracket, and then you have the loop body, and it's your responsibility to remember. While you're programming that loop body, it's your responsibility to remember to code the progress in there. The progress in a for loop tends to be very incremental and sequential. We're doing this once, twice, 3, 4, 5, 6. Once we get up to 10, we're done. In a while loop, it can be that way, but it doesn't have to be that way. Sometimes in a while loop, the progress is going to be more, I don't know, episodic, right? So sometimes you're making progress, sometimes you're not. There's no guarantee that the path you're on is currently contributing direct to the end. If you think about writing a program to do a dungeon crawler or a maze crawler, and you can go down the wrong path in a maze, you don't know if you're making progress towards the exit or not. Temporarily, you are not. In the long run, you are, because your software will backtrack and then try another path. The problem is you just don't know how much progress you're making at any point in time. And yet I can still convert that to a for loop. We'll see why in a minute. You won't. Don't do that, but you can. Okay, so here's a for loop example. This is all legitimate Java stuff. And all I'm doing is summing some numbers. So I ask the user to give me an integer. I take the integer, and then I sum those values. And we have our starting condition, I is equal to 1. We have our stopping condition, I is less than n plus 1. When we have progress, I equals I plus 1. Right there in the structure of the for loop, it's built in. Now, this slide just talks about the starting condition. Why are we using the variable I? That's not descriptive. Garfield, you're telling me to use these descriptive names, and now you're just using I. It's tradition. Tradition is why. This goes way back to the 50s and 60s. And even 70s, back when I was programming in Fortran, variable names could only be, at most, 1 letter and 1 number, 1 digit. X1, X2, X3. And you had to declare them. But the way Fortran was designed, if your variable name started with an I, J, K, L, M, or I believe N, it was automatically an integer and you didn't have to declare it. So people were using I for their loop counters. And that has continued to this day. It just kind of shows you're in the club, right? If you're using I, J, K for your loop counters. If you have a nested loop, you use J. If it nests again, you use K. So you will almost universally see these as your loop counter variable names, I, J, K. Even though, you know, that restriction is long gone. I recommend doing that still. This is a place where observing the tradition helps actually enhance understanding more than violating the tradition. Now, I didn't declare I, that's okay. Java is so much expecting that you're going to use I that it won't mind. You can declare I in there. You'll sometimes see int I equals 1. So that's what's happening with the starting condition. Now this starts at I equals 1. We're going to deal with arrays next week, and arrays start at 0. So almost always we're going to start at I equals 0 because that's going to be the first index of the array. But okay, so that's the starting condition. What's the deal with the stopping condition? Technically, it's a continuing condition, right? Because what are we saying? As long as this is true, continue. And then once it flips to false, that's when we stop. Well, okay, it is a stopping condition, but it's expressed as long as this is true, keep doing the loop. If this is true, go one more time through the loop and check again. Go one more time through the loop and check again. Keep doing that till it's false. That form is typical. you can put any Boolean test there. So again, I mention that because you're going to use I as less than something so often that your brain kind of thinks that's the only thing you can put there. Or I is equal to something so often that your brain thinks that that's what that's the only thing that can happen. And that's just not true. You can put any Boolean test there. You'll hardly ever need to, but it's good to know you can. And again, that could be a method call. Okay, and then the progress, I equals I plus 1. You'll hardly ever see me write that again, I equals I plus 1, because ever since the 1950s and 60s, people have been writing I equals I plus 1 and they got sick of it. So in the 80s, they came out with a shortcut, I plus plus, which just means increment I. That's shorthand for increment I. And guess what? I minus minus means decrement I. So that's what you're going to see there. Almost always, you're going to see this being replaced by I plus plus, which means increment I by 1. Now, you can put anything there. You could let I be a random number, doesn't matter. You can put anything there. You want progress, so random number might not be the best way to go. But again, almost always you're going to do this, I plus plus. Why? Because why did you use a for loop in the first place? Because you knew how many times you were going to go through. So all you're doing is counting how many times you went through. So that's why it's almost always I plus plus. But again, be aware, if you need to, if you have some odd situation, you can take advantage of that and put any Boolean test you want there, which could also be a method call. Okay. The while loop, very similar, but our starting condition and stopping condition, we have to set the starting condition up ahead of time before we go to the loop. Whoops. Before we go to the loop, so you set it up in the code ahead of time. Inside the while, and in the while statement, the only thing you have is the stopping condition. The body is inside the curly brackets, as always. And then don't forget, now you don't have the reminder. The for loop reminds you, right? It is required that you put in a starting condition, stopping condition, and progress. And here you have to remember to put the progress in. Now, in a while loop, it's usually not going to be as simple as I equals I plus 1. But I'm converting that for loop to the while loop. Okay, so it's going to be some other kind of thing that you're programming to make progress. It is easy if you get wrapped up in the logic of something that you're doing in that loop body to forget to put the progress in there. Or it is also easy, since the progress is usually something more sophisticated than just adding 1, it is also easy to screw up the logic. So be aware of that. Be careful of that. By the way, where do most programming errors occur when loops are involved? Either the first loop was set wrong or the last loop was set wrong. So always check your boundary conditions on the loop. Did the first loop do what it said it's supposed to do? Did the last loop do what it was said it was supposed to do? If I have n elements in my array, did I check the first one?
You don't have to go as long as you pass the class.
I'm
pretty sure that's why they put that. Because it doesn't anything for biology, and I'm pretty sure you don't have to pass the biology and AOC anymore.
Because you failed the class, and you had to see.
Okay, first one, and then the last loop. Did I cover the last element in the array? You know, check those boundary conditions. That's most commonly where things get messed up. And then check when you have really small arrays, like if you have an array just of 1 element, did that array get checked? Or if you have an array of 0 elements, does your program crash? Check those boundary conditions. And I'll remind you a lot of that as we go on. Okay, that's it for today. On Wednesday, we'll walk through the code. I don't think it will take the full 50 minutes. It might, but we'll see what happens then. Do we have questions before we go? None. I always hope for questions, but I suspected none. Let's put it that way. Yeah. All right, guys. Then thank you very much. Have a wonderful holiday. Enjoying your classes. And I'll see you on Wednesday.
All right, thank you.
Here.